Give the formula for the following compounds. Manganese 2 fluoride. Well, manganese has a formula of Mn, and the Roman numeral tells us that we have a +2 charge on this particular manganese ion. Fluoride is based off of fluorine, which is 1 away from the nearest noble gas. If we cross our charges, we're going to end up with MnF2. For vanadium 3 sulfite, vanadium has a symbol of V, and the Roman numeral 3 tells us that we should have a +3 charge. Sulfite is one of the polyatomic ions. It has a formula of SO3, and, just like sulfate, a -2 charge. In fact, it's the same, except for one less oxygen. If we cross our charges, ignoring the signs, we're going to end up with V2 parentheses SO3 3, which would be our final formula for vanadium 3 sulfite. We have potassium dichromate. Potassium is a well-behaved cation, so it's 1 away from the nearest noble gas. Gives us a +1 charge. And even though we said that the numerical prefixes are generally a good indicator that we're dealing with covalent compounds, in this case, we know dichromate from our list of polyatomics. It has the formula Cr2O7 with a -2 charge. If we cross our charges, we end up with K2Cr2O7 as our final answer. Now, in the final one, nitrogen triiodide, in this case, the tri actually does mean it's a good indicator that we're dealing with a covalent compound. Nitrogen and iodine are both nonmetals. So we have just one nitrogen. Again, we don't generally put the mono in front of the first one. So if there's no prefix on the nitrogen, we assume it to just be 1. But the iodide should be ×3. So Ni3 would be our final formula.